Hello and welcome to episode number 1 of Getting Started with Attributes and VOPs inside of Houdini. And this first lesson will be the introduction to attribute system inside of Houdini. We will learn how to work with attributes, how to read the attributes, what they do, what can we do, at least some basic things with our attributes. And of course, at the end of it, we'll do something practical. For example, like this. We'll create a simple motion graphics setup that will create our kind of like 3D equalizer. And all the while, we will learn a lot of neat tips and tricks about attributes, how to work with attribute VOPs, and get much more comfortable with Houdini. As per usual, I just want to say, if you are interested in supporting the channel, don't forget to subscribe to it. Maybe even check out the Patreon, because it has all the scene files, so you can follow along. And without further ado, let's get started and learn about attributes inside of Houdini. So let's talk about the attributes and see what we can do with them and why do we need them and how to better understand what it's all about, right? So as per usual, we'll start by creating the geometry, and let's just create a sphere. And you can see we can sphere create primitive or whatever. It doesn't really matter. We can place the sphere create, then switch it to primitive. And as you can see, it does looks kind of like it has nothing. It has no geometry, well, basically because it is primitive. So if we go to this icon and press the I, get the node info, you will see that indeed we have geometry, which is sphere 1, which is sphere sop, and it has 1 point, 1 primitive, 1 vertex, and 1 sphere. However, the interesting part that we are looking at right now is the 1 point attribute, which is P, which is 3FLT POS. Well, what does all of that mean is that it is a 3 float, which means it has the X, Y, and Z, and POS means that it has the position. So, in fact, the only thing that our sphere has is one attribute, which is position. In a Houdini attribute system, it is acronymed by just one letter P. We can actually look at those. If we go to on the top, we can go to the geometry spreadsheet. You will see that indeed we have the information about our points, which has the point number 0. It has the position in Px, Py, and Pz, and 0, 0, 0. If I start transforming that, for example, translate in the x-axis, you'll see that we have the position moved by negative 0.9. Here it says negative 0.9, and indeed in the scene view, we see that it does move around. So in order not to actually switch back and forth like this, the more time-saving way to do that will be split pane top to bottom. Hit here the inspector geometry spreadsheet, close this, we don't need this, and here we go. We have our geometry spreadsheet. Again, if we move about our things, you will see that it changes here and it changes here. So, as you might already suspect, the very fact that it's being transformed, or indeed translated, as it says here, in the, for example, y-axis, in 0.7, it doesn't just, we do not just tell Houdini, could you please transform it by 0.7? What it actually does, it changes the attribute of position to Py, as in position in the y-axis, to 0.7. Think about it as Houdini making it easier to track things, how they present themselves, how they position themselves, how they are rotated, translated, and other things, of course. Are there any other attributes in Houdini? Well, of course there are. So, for example, we can do the color. You can now see that we have the CD, R, G, B. Again, you can see that R is 1, G is 1, and B is 1. Well, basically red, green, and blue. As you can see, if I tweak around, you'll see that it changes here, obviously. And of course, we can see that it changes here. So now, if we add the color attribute, you will see that we have 2 points. One for color diffuse, as in CD, again, 3 float, color, and P, 3 float, position. you'll see that we actually now have 2 point attributes. Again, when we just transformed our sphere, we had just 1 point attribute, and when we assigned the color, you will see that we have 2 point attributes. Effectively, unless you actually specify the attributes that you need, Houdini will not give the attributes on itself unless it's some sort of a default that it will be defaulting to when, for example, you are rendering with Mantra or Karma or whatever. To manipulate those attributes, you can use, of course, Wrangler, like attribute wrangle, and hack the pentagon here. Or in our case, we'll be talking about the attribute VOPs first. There is, of course, the volume VOP and other wranglers and whatnot. But for this particular video and this series, we'll talk mostly about the attribute VOP and how to manipulate the attributes using that. So here it is, attribute VOP. And I will connect it now, and nothing will happen. Nothing will happen because this is a processor of these attributes. And if we dive inside, double click here, you'll see that we have the geometry VOP global 1 gets into the geometry VOP output 1. Again, that's the global input. You can think of it as we give the geometry information here. It does whatever it does. Then it outputs here, and let's just, for the sake of the illustration, call this results. So, if we dive inside, we will see that we actually have the P, V, force, H, live, ID, CD, UV, N, and other attributes that are defined by default and understood by default inside of Houdini. So, you'll see that we indeed have the P. If we connect it to the P, again, nothing will happen. You might think, why is this happening? Because we got the input, did nothing, and got it to the output. Naturally, the result is we get what we had before because, well, basically we do nothing. Basically, we do not process the geometry in any way. However, what we can do is, for example, we can add, place it here. You'll see that here is an add, and we will add to the position a constant. You'll see in a second what I'm doing. So here we have a constant. We connect it to the P. It gets here. And again, nothing happens, right? However, if I start tweaking the float default, you'll see that our sphere indeed starts moving. However, it kind of moves relatively weird, right? So if I just start adding, it kind of moves from the, if we position camera, something like that, it moves from bottom left to the top right and seemingly away from us. If we go back to our attribute VOPs, you will see that we indeed are changing the position of our sphere. It says 2.5, 3.2, and 2.5. So what is happening is that we add the transform that we had 0.7. We process it in the attribute VOP. We add, that's for the sake of easy understanding, 2.5. And now our geometry has 2.5, 3.2, 2.5. Now, of course, it's not exactly super interesting to just add one float. We can add the 3 float, which in fact is a vector, right? You will see that when I change the float, which was kind of this turquoise color, and I say the vector, it switches to green. So you will notice that the P is in green because it's a vector. And for example, age, life, time, frame are in turquoise because they're not vector information, they're floats. Floats can have decimal after the points. So 0.2982, it's a float. The difference between float and integer is that integer can be just 0, 1, 2, 3, 4, 5. So it's useful for counting things. Whereas floats, they can have increments, and basically you can use it for precision position. Now the vector is nothing else but 3 floats written one after another. In our case, if we add this 0, if we add like like 1.3 in the second float in our vector, which means we are adding information in x, y, z, remember? So we are adding 1.3 in y. From our initial position, we add 0, 1.3, 0, and the result of this is fed back into our position, and what we have is we indeed end up with px 0, py 2.0, and pz 0.0. Hopefully this makes sense. Effectively, what we're doing is we are creating the transform kind of like this. As you can see, we are transforming 1.3. Our attribute VOP does exactly the same thing. We just make it so more explicit in the attribute VOPs. Basically, we are making it obvious that we're changing the position of our geometry. All right, so this is a little bit abstract. However, hopefully this is easier to understand for getting your mind around the whole idea of having attributes, manipulating attributes, and effectively understanding that transformations or something else or scale or whatever, rotation, is actually changing attributes of our geometry. It's not that we are basically telling in some abstract form or fashion to the Houdini, like, I would like our sphere to go up in 1.3, right? We're changing the attributes of position in 1.3. And of course, we can keep track of that in the geometry spreadsheet. Anyway, that was kind of useful, but not exactly engaging, right? So what we can do is let's create something more, obvious, something more interesting. All right, so we will have the grid and we will have some, columns extruded differently based on the attributes that we will create. Okay, so we have this grid in size 10 by 10, in rows 10 by 10, which is fine by now, it doesn't really matter. What we can do now is tab, attribute VOP, shift enter, and jump inside. So what we can do is actually tap or right click and start tapping noise. And it doesn't really matter, you can take the turbulent noise, the boring noise, the wirely, pick whichever you choose, but if you want to just follow around this tutorial, turbulent noise will do just fine. So what I want to do is I want to colorize the different faces of this geometry using the noise, and then use that to visualize the colors, and maybe even use that to extrude our geometry. So how do we do that? So if we have this noise and we connect the noise just to color right now, you will see that we have nothing. Why is that? Because noise generates random values based on some inputs. In our case, the input will be position. So I connect position to the turbulent noise, so we'll see immediately that we have some result, thankfully. So what's happening is that we get each position of each point. We generate some result based on that. Of course, we can increase or decrease frequency. If we jump back inside, if we jump back out and increase the resolution, you'll see that indeed we have some sort of pattern going on. And you can see I can zoom in, zoom out of our noise, and everything will be, well, pretty much self-explanatory. We have this noise. If we jump outside, we can see that our points have now color attribute. So what happened is when we connected the noise to the CD attribute, to the color, it actually went and created that attribute for us, so we don't have to actually specifically specify that we need to create that. If there is this input, it will automatically create it. Saves a little bit of time, and well, obviously it's a little bit more visual, so helpful as well. Now, The interesting part about this attribute VOP is that we can actually run it over points or primitives or vertices. So if we run it on primitives, you will see that it's kind of like pixelated, and we will talk about that, why does that matter, in just a second. So if I do the poly extrude, Shift Enter, and here in the local control, I can write the distance scale as in CD, press Enter, increase the distance, make the individual elements. You'll see that nothing really happens because the poly extrusion happens on the primitives. As you can see, here they are. But the primitives do not actually have the attribute CD. Why is that? Obviously, there is some color going on, but it doesn't really affect it. Why is that? Because the attribute VOP runs on points, and we need to run it on primitives. And right after I switch to primitives, you immediately see the result. And of course, it looks how we want it. So that looks pretty good. Okay, so if we don't want the colorization, we can do the color. For example, we can overwrite the color with whichever color we want. Or we can do attribute delete. And we can specify that we don't need the color, which is in the class of point. In our case, interestingly enough, it was from the class of, first things first, it was from the class of primitives first. We can see that our primitives have color. Then we poly extruded it. Then we have two attributes different, one of which is on primitives and the other is on points, which overrided what we had on primitives. Anyway, to make a long story short, we can actually delete the point attribute CD, and it will go back to our primitive colors, right? And of course, we can delete, again, attribute delete. We are deleting the attributes. So to check out what we have, we can use the middle mouse button or the eye icon. Middle mouse button is a shortcut. So we can middle mouse here. You can see one primitive attribute, color diffuse. Then we have some extrusions. And then we have 2 point attributes. For example, one point attribute was color, the other position, and the primitive attribute was, again, color. So basically, we had 2 attributes of color on one instance of geometry, which is kind of weird to think about it, but, you know, whatever. And after we deleted the attributes from points and from primitives, you'll see that the only attribute we have is indeed just the position on points. The other interesting thing, the attributes are not just, position, rotation, or temperature, or velocity, or any other things you can think about it. Pretty much everything is in fact an attribute. Let's see. So we can load up the test geometry squab, and if we go inside, we can see that it has like printed points, attributes, position, materials, UVs, primitives, groups, and all that kind of stuff. So the interesting part is that we have the vertex attributes, which is UVs. So in fact, you can see that naturally we have some texturing going on. It looks kind of realistic, pretty good. However, if we can go to attribute delete, right? And we delete actually what we have. We have the vertex attribute 1 UV. We can actually delete the UV attribute. As you can see, everything immediately goes away because there are no UVs anymore. So if I bypass this, you'll see we have the UVs. If I enable it back again, the UVs are gone, which is, again, a strange way to think about what we're having, because usually you would think that UV is some other piece of information on geometry that deals with textures, with UVs, how things are unwrapped, and yada, yada, yada. However, in fact, it is just another attribute, which is a vertex attribute. And if we can delete this, we can basically strip our geometry of UVs immediately. So anyway, let's get back to our geometry that we have. What else is interesting is that, like I previously said, this geometry only has point attributes. But it kind of looks faceted and it looks, reasonably fine without any normals. Why is that? Because Houdini actually assumes, in the viewport at least, that some normals are to be expected. However, if I scroll down here, press the eye icon, and go into the geometry tab, there is the normals, auto-generate vertex normals, and the cusp angle is 60. However, if I make it, for example, 180, you'll see that it starts to look kind of, really weird, basically, right? So if I make it back to, actually, let's not make it back to 60. Let's actually write normals, right? Create normals. Shift-Enter. You'll see that, it looks better now. So previously, we did not have normals, right? It looks weird. Now that we added normals, you will see that we have new vertex attributes, which is called n, which is 3float normal. Again, 3float is a vector. Basically, if you watched the previous tutorials I recorded in the Getting Started with Houdini introduction, I explicitly told you that unless you actually specify by hand things inside of Houdini, Houdini will not presume things that you might have inside of your geometry. In our case, Houdini did not presume that we needed normals. And of course, it didn't specify those normals in our geometry. The interesting part is that, so let's see now, right? So before we had normals, you'll see that it has 1.22 megabytes in memory. After we applied normals, it has 1.77 megabytes. So basically, it takes a little bit more memory to keep in mind with geometry with different attributes. So in fact, what's happening is that when you do not need things to be kept in mind, for example, imagine this not being 12,000 polygons, but 12 million polygons. Naturally, the memory will skyrocket into, I guess, 1 and 5 gigabytes or even more. And of course, it will save our memory like 500 megabytes if we don't have the normals, right? So basically what I'm trying to say is Houdini does not append attributes that you don't need. This is why sometimes people are getting confused when they come from Maya or Blender or somewhere else when they are trying to, do simple things like copy things in a radial symmetry or whatever, copy to points and orient those points. They're not oriented by default. It's because the normals and indeed the rotation is not being pre-applied to you unless you actually specify that you need that. I wouldn't say it's a tricky part of Houdini. I would say it's a little bit of a quirky part of Houdini. But if Houdini is your, if you're interested in making the Houdini bread and butter for your actual day-to-day operations inside of like the VFX, modeling, or whichever, you will actually start to appreciate the fact that Houdini does not make decisions for you. Not someone else as a developer made them for you, so really useful. So what else can we do with our attributes? Let's get back to our grid, let's get back to our attribute VOP. Okay, so you'll see that if we jump inside, I can do the turbulent noise and I can switch the offset, not switch the offset, just move the offset. You will see that, different things are happening. If I move the offset in the x-axis, should I position it like this? In the x-axis, you'll see that our noise is kind of swimming through the geometry. However, the interesting part about VOPs, if we do it inside of here, it's not optimized. However, if we somehow promote the parameters outside of VOP, it will be compiled code and it will run much faster. So how do we do that? We can actually middle mouse button on this offset and say, again, middle mouse button, say promote parameter. And you'll see that there is some sort of like a little flag happening. If we double click here, you'll see that it actually creates a new parameter that's called offset, and it's a free float. We can hide it by middle mouse clicking and get to the hide input nodes, right? So just keep it a little bit more clean. And if we go back to our Geo1, you will see that we actually have the offset. That's pretty cool. And as you can see, it also runs much faster. So what we can do now is, for example, let's make it, 80 by 80, right? A little bit more precision here. and we can do the offset. Indeed, we can animate offset, like write some sort of like a time divided by 20, right? So it will be some procedural animation. You will see that we have some result. If we animate this and press animation, you'll see that our noise indeed is swimming through our geometry. And of course, if we polyextrude this result, you'll see that we have sort of an easy way of creating some sort of a motion graphics setup, which looks kind of nice. You know, I'm not saying it's super interesting, but it's not bad, definitely. Anyway, let's get back to our geometry. And what I want to show you is that we don't want to actually control it by CD, as in distance scale of our attribute, right? We want to actually create our attribute as we need this. So how do we do that? We create a bind export, press enter, and connect the noise to the input. Now here, it already says as the float. So again, when we want to polyextrude things, the distance, you'll see, is actually a float, and the distance scale should be a float. So getting back here, it indeed says float. All right, so next up, we can name it however we want. So for this instance, I'm gonna say distance extrusion, right? Control C, and here, if I say distance scale, distance of extrusions, nothing happens, well, because we created a new attribute. Now we can actually check out this attribute, of course, if we go into our primitive attributes, and you can see that we have the distance of extrusion, which has different values for each and every primitive. So if we make it like 4 by 4, right? Something like this. It looks really basic, but you'll see that our distance of extrusion, as you can see, we can organize it by values, we can organize by number of primitives, doesn't really matter. The only thing that we want to know is that it actually created those primitive attributes and that there are some primitive attributes. And of course, we use that in distance scale, and now we can make the distance like 10. You'll see that it looks kind of like, you know, weird stairs. And of course, if we go back to our grid, we can divide it, and it looks kind of interesting, kind of cool. Again, we do not need the colorization. We can have it, right, like this, but we don't need it. So we can delete the color attribute, and of course we can delete the attribute delete, right? Because we did not create the CD attribute. So there you go. Final thing, we can do this some sort of a polybevel. Really small distance. Whoops. Kind of like this. A couple of divisions. And it looks kind of nice. So there is that. Finally, don't forget that we actually kind of animated the whole thing, and we can preview the whole thing using this button which says render the flipbook. Let's hold down flipbook with new settings and say the size will be Full HD, and we press start. It will start creating a flipbook so we can actually see what we have. There is going to be another window. Here it is. And there you go. Obviously, when you do some sort of like a poly extrusion, then you do the normal, the poly bevel, and all that kind of stuff, it's not super real time. However, the flipbook allows you to preview your results in real time. So there you go. Looks pretty nice. Kind of like a 3D equalizer kind of thing. It's pretty easy to do, as you can see, but the whole point of this video was to actually learn more about the attributes and getting to know the attributes so that you actually can be more proficient with them. So there you go. Of course, we will talk a lot more about attributes, how to control them, like what with points, curves, all that kind of stuff. However, this one is just for you to practice and to learn more about how to use them. So hopefully you learned something interesting in this video, and If you have ideas, suggestions, don't hesitate to leave a comment. If you're interested in learning more, obviously subscribe to the channel. And thanks for watching. I hope you have a nice day. See you in the next one. Goodbye.